Welcome to this new video tutorial. In this video tutorial I will explain the improvements that have been made to the building generation functionality that's in ModelConverterX and scenProc. As some of you might know, scenProc already had the capability to create 3D buildings based on footprints for a long time. Here you see a couple of screenshots of the kinds of buildings that can be made. So buildings with flat roofs, hipped roofs, gabled roofs. You can add an additional gable, as you can see in the bottom left picture, to get slightly different shapes. But I wanted to make more realistic buildings than this, so that's why I started improving the building generation functionality. So what has been improved? There are more roof types to choose from now. You can also have segments with different heights within the same building. So for example, main building with a utility room at the end, that's for example only one floor while the main building has two floors. You can have more control over the texture mapping now, and you can add features like a chimney or a dormer to the building as well. And this functionality has been put into scenProc as it was before, but given that you can now sort of easily create a building, I've also decided to make a wizard into ModelConverterX where you can manually draw a building, which I think could be useful if you want to quickly make a couple of generic buildings. It will never replace, of course, a specific building that you're modeling in your 3D modeling tool, but if you want to have some representative buildings to put in your scenery, I think it might be a useful function. So what will I cover in this video? First I will walk you through the building creator wizard in ModelConverterX. How can you use it to quickly draw a building, and how do you define the texture mapping of that building? After that, I'll go through all the details of the building generation algorithm, so all the different roof types, all the other options that are available. And at the end, we'll go to scenProc and show you how the Create 3D building step there has changed to work with this improved building algorithm. So let's get started. Let's hop over to ModelConverterX. If you go now to Wizard and then Building Creator Wizard, you get the new Building Creator Wizard, and I've set it up so that it opens here on the side. In this wizard you see basically two areas. You have a top area with a grid. There you can draw the footprint of your building. And then you have a bottom area where you see the properties of the polygon or the edge or whatever you will select later on. But we'll come to that in more detail later. And then at the top you have two toolbars. The first one you have save and load, so you can save your building once you've defined it and load it back later on to continue working on it. With new, you start a new empty building. You can add an additional polygon, a chimney or a dormer with the buttons here. And you can remove any selected polygon, edge, vertex or feature. And a feature is a dormer or a chimney. And you have options here. So that's the top bar. In the bottom bar you have an auto gable function. I'll show you how this works later on, but that's functionality that automatically assigns gables to your buildings. You can apply modifications. These are the same modifications that scenProc already could do, so to add an additional gable, for example. And you have the texture configuration editor, which we'll also cover later on. But let's first just get started. I should also say here at the bottom you can see you have a recenter button, and you can see the modes that the tool is in. It's either in draw mode or in select mode. Since I now just started it up, I'm in draw mode. And you can also, so that means that with the mouse I can now just draw building. And when I move around, you'll see that sometimes the lines of the grid turn green. That's when it snaps to that grid line. So when you're drawing, it's relatively easy to draw an exact rectangle, for example, because it snaps. So I can just click here to add the vertices, etc. And if I double click on the last one, it will finish this building polygon. And you see, while I was clicking in ModelConverterX, the building has been updated. You already saw that I made a mistake at the end. We didn't want that last vertex there. So I can select that one now, and if I do remove vertex, it's being removed from the building. So now I have a basic building layout. I can say, let's say it should be 6 meters in height, and it should have a hipped roof. Let me center in ModelConverterX, and then you see I have a 2-floor building with a hipped roof. And like I said, I can probably add another focus now. Let me add an let's say a utility room at the end of the building. So I just draw this small additional outbuild. We can leave that at 3 meters with a flat roof. And you see that it has been updated here in the preview as well. So that's very quickly how this works. If I select this polygon, I can also say I want to add gables to it, and then it will automatically assign, as you can see here, the gables to the building to get a gabled roof. So that's how you can quickly make a building with this wizard. Since it's here in ModelConverterX, once I'm done drawing like I've done now, I can just export it to any format that I would like so that I can use it in my scenery. And as I was drawing the building, you see that it is a texture assigned already to the building. If you do it the first time, you'll have to make sure you configure a texture configuration. So you can specify what the default wall and roof texture configuration is, and with that texture configuration, ModelConverterX will then sort of map the texture to the building. Let's go a bit deeper into how that works. So here I select the texture configuration. I can set a default group, but you can leave that empty if you don't use the groups. And you can select a default index. If you have multiple textures within the configuration, you can let ModelConverterX always pick the same one. If you put -1 here, it will choose a random one. This default one will always be used, but here, if I click on any of the polygons, you see I can still modify this per polygon. So for example, if I go to that utility room, and I can maybe say that I don't want, where is it? I don't want roof index 0, I want roof index 1. In this case I have two roof textures in there, and then I get a gray instead of a red roof. And I could do the same with the wall. I could say I want wall texture 0, which probably looks a bit weird in this case, but depending on how you set up your texture configuration, that could help to get realistically looking buildings. So how does that texture configuration work? For that we have the building texture configuration editor. So let me open that one. And in here you can define which textures there are and how they should be mapped. So I'll show you the one I was using before in a second, but let's first just assume we create a new one. So in here I can say I want to add a texture, and then I need to select my texture. This is the texture sheet I've been using. I'm not a very good texture artist, so you can probably make much more realistic textures, but this should suit the purpose for this demonstration. And as you can see in this texture I'm using here, there are 3 wall segments and 2 roof segments. So what we need to do is to tell the building algorithm that there are multiple texture segments in here and how these texture segments are used. So what I will do, and let's pick this second one, this blue one I had on the building as well. You can see it's like a quarter of the texture in height and the full width. So I can set the Y size at a quarter, and then it has an offset of a quarter as well, since it was the second one. So that way I have now selected this piece of the texture, as you see here in the preview, should be used as one of the texture segments. Then scenProc not scenProc, also ModelConverterX now, sorry, the building algorithm needs to map this texture on your building. For that, it needs to know a bit of additional information about the scaling, how you designed the texture. Now it says a maximum segment height and length of 32 meters. So you need to fill that in based on how you designed your texture. This texture is, what we selected here is a 1024 by 4096 pixel segment. And I've designed it to be 32 meters in length indeed. But since it's only a quarter of the height, it means that it's 8 meters in height. So let me enter that here so that the building algorithm can use the right scaling. If I have a building that's taller than 8 meters, the algorithm will sort of repeat the texture, but often you don't want the bottom, sort of the ground floor level to be repeated because, well, here in this case it has a couple of doors in there, which would look very weird if the third floor also gets some doors. Or maybe on some buildings you have shops there or those kind of things that you don't want repeated. So here you can specify a ground floor height. I guess it should be around 3 meters here. You see it's rendered as the white of the yellow dashed line here. So that means that the algorithm for the higher floors will only use that part of the texture. And if your texture doesn't really have characteristic features at the ground floor, or if you do want them repeated, you can leave it at 0 as it was before. So that's the basic things you set here. Or if you have a night texture with your texture as well, you can add the name here. So you can specify like the building underscore LM texture or whatever. Do not worry too much about the extensions because the building algorithm will modify it to DDS textures automatically when it goes into ModelConverterX. And then you can use the material editor to convert whatever your sim needs. Now there's one last thing that we need to do in this editor, and that is to tell the builder algorithm where the doors and the windows are. Because when the texture is mapped to a building, you of course don't want that a door is split on 2 walls of your building, for example, and the same for a window. So you need to tell the building algorithm where those things are. And that's done here with this top toolbar. So let's start with the doors. I can say add semantics. I'm going to add a door. Now I'm in a mode where I can draw. So now I can draw around these doors. And I can do the same for windows. So I'll pick window. And that's a little bit of work, but you would have to do it for every window or door in this texture so that the tool can properly assign them. Let's just at least do the ground floor. And let's say I make a mistake. Oops. There's a remove semantic button as well. If I now click inside the one I want to be removed, it's gone. So that way you can modify it later on as well. Yeah. So this you would have to repeat. And you might already see, come to that in a minute, that there are 3 quality indicators here on the left, which show you how easy the building algorithm can map this texture onto your building. And while I'm drawing additional things, you see that that's changing. And we'll come to that in a second. Okay. So now we have all the windows in there. we have those quality indicators. The first one indicates how easy it is to map this texture on the building. And funnily enough, it's green. It's not supposed to be green. That's probably a small issue I should still look at before releasing this functionality. As you can imagine, if there's like the windows, like here there's a number of windows. So let's assume I want to map something that's 3 or 4 meters. You would have to, in length, you would have to make sure that you're not interrupted by those windows. So having many windows means that the algorithm cannot shift the texture segment always. So this indication should normally be red and green, indicating, or even orange, indicating that if the texture length is 0 to 32 meters, and if it's in the height between 0 and 8, how easy it is to map a texture of, let's say, 16 meters with this texture setting. And if this is all red, that means that it's almost impossible to use it on a realistic building. And the two here below are for gables. So assume you have a gabled roof and you want to have it mapped with a window or without a window, then this algorithm indicates how easy that can be done. And here the vertical axis is the slope of the roof, so 0 to 60 degrees. And you can see, for example, here that mapping like until about 8-meter building width, it's possible to map a gabled roof. That's probably because of this window here. Because here we can have a triangle for a gable easily. But if it gets wider, then it's not possible anymore. And I assume that if we remove a couple of windows here, and maybe also this one, that it becomes, and you see it becomes slightly easier because more becomes green. So this helps you to see if the texture that you've made can easily be applied. And if you want to have different textures in your texture configuration, you can add multiple texture segments like this. So let me open the one I was using in the, see, oh, now the quality indicator works. So I should still check why it didn't work initially on that one. But you can see here is the one that we were using in the tool. And you also see here those quality indicators that, especially on the ground floors, there are many windows there. Some distances are a bit tricky to map. They become red or orange. The more green or yellow they are, the easier it is to map it. And here on the top floors, it's slightly easier. That's probably because there are more empty segments in between, so that the algorithm can choose a suitable piece of texture. And you can see here I've also defined two other ones, and then the algorithm can randomly choose between them. If I want, that's probably mainly interesting for scenProc, if you want to have some data in your, some attributes in your geographical data determine what kind of texture to be used, you can make groups. Like I've now put them all in a suburban group. But let's say I find this texture is not suburban, this is more an urban texture. I can move it to another texture. So now I have a couple in the suburban group and one in the urban group. And then I can let the building algorithm only use textures from a certain group. For example, because my geographical data has an attribute that says this is an urban building or this is a rural area or whatever. So that way you can guide the algorithm in how it chooses the texture. You can do the same for the roofs. I can quickly show that as well. So for the roofs, something weird happens here, but okay. Not a small bug probably because my last wall suddenly popped up, which is not supposed to happen. Like I have two roofs here, like I showed you before, the gray one and the red one. And I have a small chimney segment, which is a special segment. If you make that this will be used for the roofs of chimneys, so the top part, which is typically quite dark. So what I did is just pick a dark area in this texture. I think I picked some around here, and that will be mapped on the chimneys. But for the roof, you can see that you might want to make a group with gray textures and then have a handful of different gray textures in there. Maybe have another group with red textures and have a handful of red textures in there. And if you have a number of basic color groups there, you can let the algorithm still randomly pick a roof texture, but then with a representative color. So that would help in, especially in scenProc, to create more variation and realistic looks. I think if you do it in the wizard in ModelConverterX, you don't really need the groups that much, because there you will typically manually select which index you want to use on your building. Okay, so that's the building texture configuration editor. Let's close that and go back to our building. Because I said there have been a number of improvements to the algorithm, so let's just go over them in more detail. And I guess I'll start with a new building for this. So let's keep it simple. For this, I'll just make a rectangle, and let's go over the different settings that are available. What I didn't mention, by the way, if I hold my right mouse button, I can drag this drawing area around, and with my mouse wheel, I can zoom in and out. And the sort of the big grid that you see here is always 1 by 1 meter. So here it's subdivided more, and if I zoom out, you only get the 1 by 1 meters. And if I press this center button, it will reset to the default center zoom again. So especially with a slightly bigger footprint, it might be a useful thing to do. Yeah, let's first have a look at, so I drew another polygon, I've selected it. Roof type. We have a number of roof types. So we have flat, hipped, and mansard roofs. And flat is what you see here. Hipped is what we saw before, is the hipped roof. And then we have the mansard roof, which is new. And you should basically see it as a hipped roof with two different slopes. So you can have, and you can define them here as well. So you can define the first slope and the second slope, and then also a distance along the sort of along the edge of the roof, after which it will change from the first to the second slope. So for example, if we change this 2 meter to 1 meter, you can see that the 30 degrees slope becomes less, and then the 10 degree slope becomes more. So this can be used to make like a, for example, if I make this one a bit the slope a bit higher, you can imagine that you can have different shapes with this. It doesn't have to be that the second slope should be less than the first slope. I mean, you can also reverse it, and then you can get this kind of roof structure. So this gives you flexibility to make more variation in your roofs. Let's quickly reset it to what we had, roughly what we had before. I'll do it like this. We'll go back to the roof. Now for the gables. You already saw in the first bit that I can auto assign gables here. Then it will automatically pick the sort of the short sides of the rectangle and give them a gable. But if I want, I can also finally control that. So if I click on any of the edges, you can set you now see that this one is a full gable, this one is no gable, full gable again, no gable. But I can modify this one and say, oh, I don't want a gable here. And then you see it's automatically updated. You can also have a gable on one side, or do those kind of things. And if we go to the mansard roof, you can see slightly better what kind of representations you can get with that. Let me put this back at 2 meters. So For the mansard roof, you can also do, show you that on this side. So that's that one. So it has no gable now. I can do full gable like you see here, but I can also do a half gable, and that's only available for this roof type. And then you get a gable for the sort of the first slope section, but the second slope section will not have a gable but will be hipped. And this, I think this is a style that you sometimes see on farms at least in Europe. So it's nice that you can get this kind of roof representation that way as well. So that's the different roof types that you can do. And then there's one more thing for roofs that's interesting to show. Let's go back to the hipped roof for now. So we covered the roof type, the slope, and the slope to distance for the mansard roof. We covered the textures before. There's an overhang. With that, if I put it at 1/2 meter, I can have the roof slightly bigger than my building, so that it has a bit of overhang compared to the walls, which can look more realistically for certain areas in the world. And you might already see if I pan around, to keep the number of polygons low, I've decided to not render the underside of the roof. So only the top side is being rendered. So if you get like very low, it might look a bit weird, but I think since buildings are typically mainly used from the air, it can be a useful function to make the buildings look a little bit more realistic. And of course we shouldn't overdo it, like if we give a huge overhang, it doesn't look realistic anymore. But if you keep it reasonably normal sizes, you can get slightly more realistic looks than with the default of 0, which might look a bit simple. You can do a negative overhang as well, but I don't think that's useful in any normal situations, because then you get a sort of shrunken roof on your house. So that's not something you want. So that's the overhang, and you can do the overhang with any, and not with the flat roofs. Like with the flat roof, it's not being used, but also with the mansard roof it works. And you can see here then that this roof is extending over the gable and here at the top. Okay, so those are all the options that are available for the roofs. The walls only have the height, which I covered in the earlier section already. Let's add another polygon. Let's say I have on the side of this house, I have a garage or so. So I have this outside extension. On the edges, I also have a texture mapping preference that I can set. And this is something that you can only do in the building wizard in ModelConverterX. You can't do this in scenProc. By default, it's on no preference, but let's say for this garage, I really want to have a door at this front segment, since that's where you enter it. And on the side, I want no semantics, so I want completely wall, then I can set that. And you see here, we got the door now. We didn't get the segment without windows, probably because there is none available in the texture with sort of this length. This segment is around 6 meters in length. There is no ground floor section of 6 meters without windows. So you give a suggestion. I can try it here at the back as well. Maybe there it works. If I say no semantics, then you see, then we get a section without windows. So this gives a suggestion to the texture mapping algorithm that you want certain things to be present there. And I have a choice between no preference, which just picks any segment that fits. You can say I want only windows, I want only doors, I want doors and windows, and I want no semantics. So I want basically only the wall. Those are the choices you can give, and then the algorithm tries to do as you instructed. If not possible, it will fall back on a different preference. So for example, if you say I want a door, but you have a relatively wide wall and there is no segment with only a door of that width, it will instead give you a door and some windows as a fallback. And if that's also not possible, it will default to the no preference in the end. So this way you can control how the texture is being mapped on the building within certain degrees. Then it should still be possible to find that texture, of course. And if you look closely, maybe you saw it already, I just spotted it. I've made a mistake here. This vertex is not where I want it to be. And that reminds me that I only showed you how you can draw the polygon, but you can also make modifications to it. If I have selected this vertex, and if I now press the Control button and keep it pressed, so I hold it, I can move that vertex around. So now I can snap it to where I want it to be. I already showed you how you can delete, I can do it again. You can delete a vertex. I could also delete an edge. I'm not going to do it here because then we have very little left. And I can delete the whole polygon. And what I can also do, I have now the edge selected. If I press Control and then click, and I kept Control pressed since I have the vertex now, I can split an edge. So if I edge selected and keep Control pressed, if I click somewhere, then I will split the edge at that location. So that way I can add additional points to my polygon if I want. I'm not sure if this turns out to be very realistic building, but I guess you get what I mean. So that's for editing the polygons. And well, let me just remove this garage now since we don't need it anymore. For the building itself, let me put it back on a hipped roof, because there's one more thing I want to show you. Now we also see that we have a couple of leftover vertices here on the building from where before we had the intersections with the garage. So let me clean that up. One thing we didn't cover yet is the additional features that you can add to the building. So I have this polygon selected now. I can say I want to add a chimney to this building. And as you see here now, the algorithm automatically placed a chimney, but I can move it around here as well. So if I drag the red dot, I can move it around and place it on my building where I want it to be. I'll just leave it here. If I drag the blue dot, I can rotate the feature, which in this case I probably don't want to do. And if I drag the green dot, I can modify the size of the chimney. And as you see, we should make sure that it stays on the building, else it will render very weird. And here in the properties of the chimney, I can still set the height. And 1 meter in this case is the height from the highest point of the roof to the top. So this side will be taller depending on the slope of your roof. And I can specify the texture that's being used for the wall and for the roof of the chimney as well. So you can control how it looks. And like I explained in the building texture configuration editor already, if you have a special group called __ chimney in capitals in your texture, that one is picked for the roof automatically. If you don't have it, you can choose a roof normally. But having like red tiles on top of your chimney looks a bit weird, so that's why I added that functionality. And then if I go back to my roof, I can also add a dormer. So I click again, you see it's placed on the roof automatically. I can drag it around like before. I can also make it a bit taller, and you see that the texture mapping is updated automatically. And for the dormer, I'll make it a little bit smaller for this demo. We have a couple of choices still. because we have a roof type and a slope for the dormer as well. Now we have a flat roof on the dormer. Let me make it a little bit more obvious. I'll give it a gray texture so that you can slightly better see it. Zoom in a bit as well. So now we have a flat roof. We can also give it a sloped roof, and it just fits as you see here with the, let me reduce the slope a little bit. So with the sloped roof you can, yeah, see it's the dormer roof is also slightly sloped. It should be, of course, the slope should be less than the slope of the building, else they will never intersect. But you sometimes see this kind of dormers. So we have flat and sloped, and we can do hipped as well. I think for hipped I can increase the slope angle a bit again. So then you get a hipped roof on my dormer, and you might have guessed it, there's also a gabled hipped roof, and then you get a gable on your dormer. So those are the different types you can choose for the dormer. And if you have like this gabled or hipped dormer, they work best for relatively narrow dormers, because you can imagine if you make the dormer very wide, like here, then you get artifacts. The algorithm is not really supposed to do that. I don't think in real life you often see a hipped dormer that's so wide, because that's not realistic. Or you should reduce the slope. And in this case you also see that there's an issue with the texture mapping. So the algorithm couldn't find a suitable segment to fit on here. But if you keep it to sort of realistic sizes, that will work quite well. And of course you can have, oh sorry, pressed the wrong button. I didn't want a chimney, I wanted to add another dormer. Of course you can have multiple dormers next to each other. So let's say I have, okay, the same slope, same roof. So you can have two next to each other as well. Getting whatever building looks you want. Yeah, I think that covers all the details that you can do with the building algorithm in this way. So let's hop over to scenProc to see what has changed there. So now we are in the scenProc tool, and I'll just open the script that I prepared. So in this script I'm loading buildings for an area in the Netherlands. Those are just typical footprints. I'm adding an attribute for the roof type to that. Initially I give all the buildings a flat roof, and then I give all the buildings that have less than 6 vertices and where the shape of the footprint is so that they're almost rectangular. So at least, oops, I pressed the enter key by accident. I give them a sloped roof attribute. And then here I have a couple of create 3D building steps that make the actual roof. And I'll just add another line for you so it's slightly easier to see. Because the arguments of this step have been modified with the changes I made to the algorithm. So first you have the filter, which selects which features you want to use. So for the first one it's roof type flat, for example. Then I have the height of the building. Here you can see I use 3 semicolon 4, so that means a random height between 3 and 4 meters. I have an altitude of the building, which I set at 0 here. Sometimes you might want to use altitudes from elevation data in your buildings, but we'll come to that in a second. Then you'll typically get that from some attribute. I have the roof type here, and for the roof type I can select, you see it in the help here as well, I can select between flat, hipped, gabled, mansard, mansard gabled, and mansard half gabled, and that yeah, that matches the different roofs I've just shown you in the building creator wizard in ModelConverterX as well. In scenProc you cannot assign the gabled edges yourself. That's always done with the automatic algorithm. But then we have the slope of the roof, which is 0 of course for my flat roof. But here with the gabled roof, you see I do between 30 and 40 degrees. I have slope 2, which is for the mansard roof, the secondary slope. You could assign that randomly as well to get a bit more variation. We have the slope to distance for the mansard roofs, which is 0 here in all the cases, but you can put a distance there if you use the mansard roofs. Then I have the overhang, so that's the amount of overhang in the roofs, which is 0 here, but I can put in a value like before. Then we have the modifications, and there I can do additional modifications on the footprint. You see them here in the help, sort of second bit of the help text as well. It can be none, which is what you often use. You can do an extra gable on the rectangle, so that adds an additional gable somewhere on the side of your rectangle. That gives you a look. I guess for some North American areas, that gives you a style that you see there often. I think in Europe it's less common, but at least it gives you flexibility in how the house should look. You can also do an extra rectangle for an L shape, which will make sure that on an L-shaped building you get 3 gables instead of 2. And these were the functions already available there. Now you also have an add chimney, add dormer flat, add dormer sloped, add dormer hipped, and add dormer gabled. And those are the options to add the dormers and the chimney to the building. And then the algorithm will make sure that a chimney or a dormer is being added to those buildings automatically. So those are all the modifications you can do. And then you have the wall texture configuration. So that's the building texture configuration file to be used for the walls. And you can specify what group from that configuration file should be used. You have the roof texture file and the roof group. And then you have additional options. They are explained in the manual, but those mainly control how the buildings are, like which flags are put on the object placement for Flight Simulator, or you can specify some debug output to be made. So those are all the options you have available in scenProc. Let me remove this line. So what I did here is all those with a flat roof. I made a 1-story flat roof with a chimney, and the wall and the roof texture configuration that I showed before. Then for the sloped roof, I say if the random number of this feature is bigger than a quarter, I'll make a sloped roof with a dormer, and if it's less than a quarter, I will do it without a dormer. So we get quite a few dormers in this case. And oh yeah, I do a gabled one with a dormer, and the other ones are hipped. And of course you can make more variations here depending on how your area should look. So in this case I have 3 steps to create buildings. And what I do here is in the end I use a merge scene step to merge all these buildings into one object that's then being exported to the scenery. So if you have a lot of buildings in an area, it might be more efficient to create one MDL file, one model with all the buildings in there for let's say an area of a couple of 100 meters in size, because that's more efficient for the sim to render, else you will have a lot of individual buildings being placed. This is also where the altitude field comes in again, that I mentioned before. This only works, of course, if all the buildings have a proper altitude assigned, so that they follow the terrain elevation correctly. If you do not have elevation data available, then you better create just individual buildings and leave them at altitude 0, and then they're all placed at ground elevation in the area where they are in the scenery. You can also give them an absolute altitude, and then you should specify that the altitude is not above ground level but above mean sea level, which is one of the options you can set in the last options argument. And then you can have them have a big model sort of following the terrain correctly. I've used that on projects that did whole sort of small countries, whole US states like sizes, and then it really helps to keep the performance well. So here in this case I do it. It is an area in the Netherlands. It's very flat, so I just leave it at 0 now for this demonstration. So if I run it, it will create the BGL file with those buildings. So let's hop back into ModelConverterX and I'll load that BGL file for you. And as you can see, we have flat roofs with dormers, we have gabled roofs, we have a couple of hipped roofs here. You see that it's, I see a bug here in the texture mapping now, which I didn't see with testing before. So another one to write down and have a quick look at. And you see like the 3 different wall textures that are in my texture configuration and the 2 different roof textures. And it looks a bit messy because the textures I designed are not really realistic for for how a normal area would look, but I guess it demonstrates the purpose of the tool. Okay, so that was this demo. Now there are 2 other things I want to discuss in this video with you. The first one is to give you a little bit of an idea. Can you do also slightly more difficult buildings with this algorithm? Like until now we've shown relatively traditional houses with maybe a garage or a utility room at the end, but that's about it. Could you make a generic church or like a sort of urban classical or at least older building with it? And I think you can do it to give sort of a generic representation of such features. So let's have a go at this first one. So you see here, this is just like a tall city block, about I guess at least 100-150 years old, as you see in many European cities. But the main challenge here is at the top you see there are sort of additional windows. It's more like a dormer actually, and that's also, if you want to model something like this, I think you can do it quite well with a mansard roof with a dormer. Let's have a look at that. So I go back to ModelConverterX to my wizard. I'll say I want a new building. You also see it clears the preview. So let's see, how do we get here? I'll just make a relatively big rectangle for the block. We'll directly make it, let's say it's I'll make it 12 meters tall, so we have multiple floors directly. Let's see which of my, well, actually none of my textures is really suitable, but let's pick this one. I also see a small issue here with the texture mapping. It's not completely doing what I expected. Another one to put on the list to do before I release this functionality to you all. So let's give it a mansard roof with gables, and in this case I'll make the first one quite a high slope, and then the second one a little bit less. And you see now it looks very weird because I gave it a much too great slope to distance, but let's reduce that a bit. So now you see we have a relatively sort of high sloped area here on the side. Maybe we can do it a little bit less. Well, maybe 80 wasn't too bad. And then a lower sloped section on top. And if I now on this high sloped area, let's see where we get. I'm drawing on the other side. Look, if I put here a a dormer. It should probably be a very narrow dormer with, what did we have there? I think we had a hipped roof, right? Hipped gabled probably. So then you see, we should even make it, it's still too big. Well, now it's a little bit too small maybe, but you see that we can get the kind of look, and of course to make it look better, I think you would need a better texture than I have. But you see that with the gables, and if I put a couple of them here, you can get the kind of looks that you want for that building. So that's one. And the second one was, this is actually a model that I made years ago of a church in the city where I grew up. But this is a relatively simple church. It has like a, the back of the church is a crossed style with a hipped roof, and you have the tower there. Could I make such a generic church here with the building wizard as well? Let's give it a try, because I think we can. I'll just reset this. We're in draw mode. So let's say I have, this is also something that you didn't see before, but if while drawing I make sort of mistake to make a self-intersecting polygon, then it's rendered in red to help you realize that you should modify your look. Okay, let's, I mentioned it before, I'm not going to do it again. The textures that I made are not really realistic, but you can see now I have the sort of the basic shape of the church. Can I add a tower to that? I think I can. This is not doing what I expected. I'm in select mode. I thought I said add a new, well, sorry, pressed the wrong button. Instead of add polygon, I did new building. That was not that smart of me. So I'll quickly have to draw our building again. Let's see. This is roughly what we had, I think. Slightly different shape probably, but that should do. Put that in the center of the view again. That's interesting. Why it's not, oh, it's a generation error, right? That's another thing. Sometimes the algorithm fails. Not sure why. I wanted a gable here, it didn't like it now. In that case, you should just modify your footprint until it works again. It's usually related to the so we have a, that's maybe a bit overkill. So we have the back of the church and a tower, and in that tower I think we can get away with, let me see how I'm going to render that. I do this one, this one, this one. Let's see, I made the tower 8 meters, so let's say I do this one 11 meters. And this one will get a mansard roof where we get, let's say 20 and 60 degrees. Lower this distance a very bit more. Well, you can see that with this you could make sort of a generic church relatively quickly, to have a shape that looks like a church and make maybe some small variations on that. So even sort of more special buildings you could do with this wizard, but of course always in a generic way, because that's the aim of this algorithm. If you want to model an exact church, you need to use your Blender 3D Studio Max modeling tool. That's almost the end of this tutorial. This showed what's possible, what functionality is there. There's one sort of dream or hope that I have, and that is that for scenProc, that I can use this improved building algorithm together with some detection of roof shapes from an image. So this is a screenshot from a piece of imagery that I've made for a project, and sort of my hope or my dream is that in the end scenProc can sort of detect in the imagery that this roof has a hipped style, this one has gables, this one has an additional sort of, or here you can see there's an additional gable here. That is the one with a dormer. Well, if we look closely, we can probably find one that has a dormer, or where is the chimney, to be able to recognize those kind of elements in the imagery, and then use the algorithm that I just showed you in this video to create a 3D building that matches with the image of that building as good as possible. So that's something I will continue to work on now that I've finished these improvements in the algorithm. I've no clue yet how easy or how hard that's going to be, so it might take a while to get there, if I ever get there, but that's the next challenge I set for myself. For now, I hope that you liked this video and that it gives you an idea what you can do with the building creation wizard. If you have any questions about it, just post them on the FS Developer forum in the ModelConverterX or the scenProc section, depending on which tool you're using. And I hope you have fun using this tool. Thank you for watching.